Okay, it says it's live. I'm looking at YouTube just to see when it starts there, and then I'm going to mute that window. We are live on YouTube too. Woo-hoo. What's up, everybody? How's it going? Good morning, GM. Good time of day. I see some of y'all know the drill already as we're getting started. You've been putting in like where you're from, and it's ridiculous because it's all over the place. Some of y'all been here for like 45 minutes just hanging out, chilling in the chat. I love it. So yeah, welcome to the boot camp. You made it. While everybody's getting in here, I guess we'll go ahead and do some quick introductions. We'll kick it off. I'm Richard. I'm one of the developer relations engineers here at Chainlink Labs. We've got me doing today. Day 2, we have Sol. Sol, do you want to say hello?
Yes, hello everyone. Welcome. And it will be a big pleasure to be here with you. I am a DevRel engineer like Richard, and it is my pleasure.
Awesome. So day 1 is me. Day 2 is Sol. Day 3 of the bootcamp will be Dave. What's up, Dave? How's it going?
Hello. Good to see everyone again. Looking forward to this week with you all. Thank you for showing up. So great seeing chat right now.
Awesome. Yeah. And like I said, people are dropping in the chat where they're from. I saw somebody there with an awesome name. Their name was Richard. It's always good to see another Richard around. Yeah. So, man, we got people from Venezuela, Brazil, Ireland, all over the place, India, United States. Yeah, this is going to be a good boot camp. I hope you're excited. We're going to go over a bunch of stuff in this boot camp. So on day 1, we're going to have basically an introduction, super fast introduction to Solidity. We're going to talk about ERC-20 tokens, ERC-721 tokens, figure out what all that is. We'll deploy some code. It's going to be awesome. If you see here, like deploy code, and you're thinking, I don't even know what's going on. I'm just here because it said it was for beginners. Do not worry. We've got you. You will be successful. I guarantee it. I'm like, oh man, that guy from the Men's Warehouse is a throwback to like way back in the day. You're going to like the way you look. I guarantee it. Anyway, so we've got that today. Tomorrow, Sol's going to talk to you about oracles and our data products, I think. Is that right, Sol?
Yes, and tomorrow, using a ERC token like we learned today with Richard, tomorrow we are doing a staking application. So this will be new, a new project for you.
Awesome. So today, basic coins. Tomorrow, a staking application. And then on day 3, Dave's got you covered with CCIP. And so he will talk you through that. Do you want to give a little bit of a preview for that, Dave?
Yeah, we're going to have a lot of fun. We're going to create a cross-chain token on Ronin and use a bunch of different tools. We're going to use Foundry. We're going to use Remix. We're going to have a lot of fun. And it'll be something that you can follow along with. So looking forward to it.
Yeah, awesome. Sounds good, Dave. And yeah, somebody asked in the chat, is this beginner friendly? It absolutely is. If you're a complete beginner, you're going to be fine. We got this. The other question I've seen a lot is this going to be recorded? Yes, it's on YouTube. So you can back us up. You can back us up and rewatch us again. You can repeat things, slow things down, everything like that. If you think that we talk too slowly and you want to like speed run this, just wait a little bit and then you can 2x us. So yeah, it's awesome because YouTube will let it be like recorded for us. So at any point you can just go back. If you get stuck, whatever, need to go over something a couple times, just drag that little slider back and rewatch it. I don't know anything else before we dive in. Y'all good? Okay. Well, with that, I guess I will say goodbye to Dave and Sol.
Yes, bye.
Sol will see you tomorrow. Dave will see you on Wednesday. And I'll get my screen shared here in just a second.
Have fun.
All right. So I think we like this view. How's it looking? Okay. So today we're going to talk about introduction to Solidity. We'll talk more about Chainlink tomorrow, I think. Is probably the best way to do this. I think I'll go like this. So I hope y'all are ready. Let's dive in. This is me. I'm Richard. I'm one of the developer relations guys here at Chainlink. My Twitter there, TheRGDev. If you have questions, the DMs are open. Feel free to hit me up. If anything after this, you have questions, anything like that, let me know. I'll do my best to keep an eye on the chat. There's quite a few of you. It's awesome. I'm really excited to see that there are currently like 859 people watching this. That's bananas. So yeah, I'll try to keep an eye on the chat. If you have questions, just pop them in the chat. I'll do my best to answer them as we go through. I do really like interactive boot camps like this. So I'll do my best to not just like talk and talk and talk. I'll pay attention. I am going to ask you questions as we go through. So be ready with that. And yeah, let's get started. So today we're going to talk about smart contracts, Solidity fundamentals. We'll talk about libraries, not the kind that books are in, but the kind that code is in. We'll build out an ERC-20 token and an ERC-721 token or an NFT. And then that'll be it for today, I think. Tomorrow, I think we'll get the introduction of oracles. So smart contracts and Solidity fundamentals. What are smart contracts? That is a good question, right? They are contracts that are smart. Simple, done. Basically, you can just find them by reversing the order of the words. No, they are computer programs. I like to think of smart contracts as a computer program that is on a blockchain and it's immutable, and anybody can call it, right, in the functions that has permission to do so. And there's nobody in between you and that program running, right? So within a blockchain, you can call a smart contract. When we talk about blockchains, to just kind of set the stage, make sure everybody's on the same page with me and my crazy view of what a blockchain is. Blockchains are going to be just a network of computers, different nodes in that network that are basically all looking at the same ledger and agreeing on transactions that have happened, right? And so this is where that power of blockchains comes in, because you have immutable things. So once they've been written on the chain, they're there forever. That doesn't mean you can't change things, but how they change is going to be immutable. We also have the ability to be distributed, right? So there's a bunch of different nodes running in a blockchain. That's one of the great things about blockchains as well. And then a lot of times they are going to be, this trustless environment where anybody can spin up a node, depending on the blockchain. But I'm kind of getting ahead of myself. So smart contracts are written in a bunch of different languages. The language that we are going to be using in this bootcamp is Solidity. Solidity is a high-level object-oriented language that is compiled. If you're familiar with like JavaScript, it's going to look really familiar to you. It's pretty easy to just read through it, understand what's going on, and kind of get a sense for what's happening, because the words that it uses, how it's written, is fairly user-friendly. Because it's a compiled language, it takes that user-friendly code and compiles it down into bytecode, and that's what's actually deployed on a blockchain. So just kind of something to remember there. And if I'm going too fast, things don't make sense, again, feel free to just pop in the chat there, ask questions. It's like somebody's asking, do you have to be familiar with JavaScript or Python? No, you don't. For this, it's going to be a lot of copy paste and just kind of follow along. So you'll be able to follow along easily. And if you're learning Solidity, if you don't have to know anything as far as coding in another language, it can be helpful to know how to code if you're learning a new language. But that's about it. Cool. Somebody was asking, a node is part of a computer network. So in what I'm talking about here, blockchain is made of a bunch of different computers. Those computers are commonly referred to as nodes. So it's just a computer. Man, y'all are asking a lot of great questions. So somebody pointed out that, like, who owns the blockchain? It depends. When it comes to a blockchain like Ethereum, nobody owns it, because anybody can spin up a node within that network. When it comes to other blockchains, like, you could create your own personal blockchain that you owned. So it's a it depends question. Cool. So what is Solidity? It's the language that smart contracts are written in. It is a language that smart contracts can be written in. Is probably a better way to say that. Cool. Let's move on to the next question. Or sorry, next slide. Next question I saw somebody's asking, does each host Does each node host the blockchain? So yeah, within the blockchain, each node basically has their own copy that they're agreeing with each other on. Cool. So within a smart contract, they have a basic structure. And this is like a super boring way to kind of lay it out, right? They have like weird things: pragma directive, contract declaration, state variables, constructors, functions, modifiers, events, imports. Like, what is all this? We're going to get to this in a little bit as far as looking at it, but I thought it might be easier to actually look at some code here. And with this code, you can kind of get a sense for what some of these things are, right? So this is a smart contract. And, you know, we mentioned here like pragma directive and contract declaration. We'll start with those two, right? So up here we have this pragma, solidity. What this is this is saying, hey, this code's compiled. Remember I said we're taking stuff that looks like this, right? Like you can read this, right? Address, private, owner. It's pretty simple to read. This gets compiled down into bytecode, which is what the computer reads. So pragma, solidity, and then the version says what version of the compiler you're using. So in this case, you know, it's saying it has to be greater than or equal to 0.7 and less than 0.9, right? But this is just saying what version. We also mentioned the contract declaration. So that's right here. We're saying contract. This contract's name is owner. This is just an example contract. Don't worry about what it's doing. We're just talking about pieces of code here. We also have in here state variables, constructor, and functions. So state variables. So variables look like this. This is a variable. It's called owner. It's a type of address, and it's private. Right? So this is telling you about this variable. We have the constructor. The constructor is a special function that gets run when the contract is deployed. Okay, so the constructor runs the first time, like when you deploy this contract, and it's used to do things like, you know, set the owner here. It does a few other things. We'll look at this a little bit more in depth here in a moment. We have functions and events. So a function right here, it's just a piece of code that you can call. Events happen, you know, when we like do like an emit here, this owner set is an event. So this is basically a log. It's a piece of information that gets stored on the blockchain. It's an event that gets emitted. Cool. So different parts of the contract. These are like the main basic pieces of a Solidity contract. So y'all, I'm not going to be able to keep up with all these questions. Y'all are asking a ton of great questions. I will do my best to go through and catch them. And I think too, a lot of them that I've seen go by will be answered if you just hang out for a little bit, right? So somebody's asking like, what IDE is this? This is called Remix. We'll get to it in a moment. Somebody else was asking like, you know, is the constructor when the gas is used? Because they probably saw right here, this infinite gas thing. So gas is the way that we pay for essentially things to happen in a blockchain. And so, yes, like when the constructors run, that's going to cost gas. When this function is run, that'll cost gas because we're actually changing something. We're making a change to the blockchain. And we'll talk about this more in a minute. But some functions like getOwner, it's a view. That means it doesn't actually cost gas because you're just reading from the blockchain. Cool. Y'all are asking great questions, so keep it up. Okay, so we talked about the pragma, right? So this is going to be the compiler version that we're using for Solidity. So we talked about that, right? It's up at the top. We have state variables and we have parameters. So these are two different things within a Solidity contract. So state variables are going to be stored on the blockchain. They're going to like always be available, right? So we're actually storing information on the blockchain versus parameters, which only exist during execution. And this is a pretty big concept to be aware of. When you're storing something on the blockchain, one, it's going to cost gas, right? Two, it's going to be there and like available permanently. There'll be a record of it forever. Parameters that are temporary are stored within like the computer that is running your functions before it stores that information on the blockchain. So looking at this here, when we have owner, for example, that's going to be a state variable, right? Because it's stored on the blockchain. But the message.sender, for example, is going to be a parameter because it's not stored on the blockchain. It's a value that's passed in when you're actually running this code. So anything that's used just temporarily within a function, those are going to be your parameters. Anything that you're actually storing on the blockchain, that's going to be your state variable. So yeah. Oh man, Dexter, I'm sorry. I am team light mode. Just turn down your brightness. I know for some people it's terrible, and I apologize. I was team dark mode for a while, but you know, then I saw the light, and here we are. Yeah. So just looking through the questions real quick as well. .sol is the file extension. Yes. So .sol here at the end, that's going to be the file extension for Solidity files. This is a great question. Somebody's pointing that out. Can you share these slides? I absolutely can share these slides. I probably should have done that at the beginning, huh? Give me 1 second here to copy paste. All right. So that should be the slides there. You should be able to access them as well. Yeah. So state variables, parameters. We've also got the constructor. We talked about that, right? The constructor's run at the beginning. It's run once during deployment. Primary uses, things like setting initial state, assigning ownership, basically setting up everything for the contract. So we can see that here, our constructor, right? It's assigning that ownership. It's setting up that initial state for the contract in this little example. And then variables have different visibility specifiers as well. So public, external, internal, and private. So public means anybody inside or outside the contract, they can access that value. It's basically public, right? Like anybody can see it. External means it can only be accessed from the outside. And that's kind of, this is a weird one because external variables can't be accessed from within the contract, but anyone else can see them. It's kind of strange to think of it that way. Internal is basically the opposite. It's only accessible within the contract. And then private is only accessible within the contract. Sorry, internal is accessible within the contract and contracts below it as well. So if you were to import it, you would be able to access that as well, whereas private is only accessible within that specific contract. We also have the ability to restrict access and have access control to things through modifiers. And actually, the example that we were looking at just a second ago has a good example of this. So we can say here that we're setting this owner value, right? And the owner value is going to be only able to change the owner, and it has this modifier on it, is owner, right? So this function, change owner, is public. That means anybody can call it, right? So we've got that set there where it's public, but then it has this check, is owner. So is owner is up here. It's a modifier. And what it says is it requires that the message sender, so message sender is the person who is actually calling this function, is the owner, right? So this equal says, you know, make sure that it equals the owner. So this returns true if the person calling this is the person who we stored as the owner. So that is a modifier. That's how you have access control and prevent people from doing it. But this could be called by anybody. It's just they won't be able to do anything when they try to call it because, you know, they'll get this error message that they're not the owner. So access controls, we use those modifiers to put those restrictions in place, right? This is how we have role-based, owner-based functions, stuff like that. And yes, equals is similar to JavaScript's equals. one thing to know, just like in programming, often equals like this, a single equals, that's an assignment. So we're saying owner is equal to, we're assigning it to the value that's in message sender. Whereas when you see two things like equals equals, then you're checking, say, does this equal? Or, you have this one here, a exclamation point and an equals that's not equal to. So here we're saying it's not equal to this address, right? So if the new owner is not equal to this address 0, we're checking to make sure it's not equal to just an address of 0. And if it is, we'll throw this error message. Good question. Can't see the code properly. Zoom in more. 250%. Hopefully you can see it now. If I zoom in anymore, we'll be cutting off lines. Cool. All right. So after we've talked about our permissions and access control, we have this thing called an application binary interface. Whew, what is that? If you're familiar with an API is very similar. It's basically a way for smart contracts to communicate out, like, here's how you interact with me. So what do they look like? If we go in here to the compiler, down here at the bottom, we can grab the ABI. I'm just going to get rid of this contract and paste this ABI in here real quick so we can take a look at it. So this is ABI. It is a JSON object. So it's basically just describing things. So you can see here, we've got things like our constructor is set there. We've got this inputs for our function new owner. Remember we saw that just a minute ago? Change owner, which takes in a new owner, right? So we saw that a minute ago. This basically describes what you can do with the Solidity contract. Get owner as well. You can see here, it's a function. It outputs an address, right? So the name is get owner. It's a function. That's a view function. And it outputs an address, right? So if we go back and we look at get owner right here, you can see it's a function. It's called get owner. It's a view, and it outputs an address, right? So it's basically just telling you, hey, this is how you can interact with this contract. Cool. There's a lot of questions here too about like, what are things, what's this require? What's this, what's that in this code? We will talk about code in a minute, a little bit more. So just keep those questions in the back of your brain. I bet I'll get them answered shortly. Cool. So that's like the fastest introduction ever to Solidity. We're going to talk a little bit more about it. We're going to get into it here when we actually deploy some code in a minute. And then we'll understand everything that's going on. Don't worry about the code I was just showing you. It's just some example code that comes from Remix. And we'll talk more about specific code here in just a minute. Before we get to the code, though, we're going to be talking about two things that we've got going on with token standards. So on the blockchain, we kind of all need to agree on standards, right? So we all have an idea of like what everybody's expecting and saying and stuff like that. We have two different types of standards. So there's an ERC. If you remember earlier, we talked about we're going to be deploying an ERC-20 token. And then there's something called an EIP. So ERCs are going to be smart contract standards, and EIPs are going to be protocol standards, right? So ERC stands for Ethereum Requirement Comment, and EIP is an Ethereum Improvement Proposal. So ERCs are for contracts. EIPs are more for the protocol itself. Okay, so this is just kind of something to keep in mind. You'll see them often, they're just referenced, like here we have ERC-20, which is for fungible tokens, and ERC-721, which is for non-fungible tokens. We'll be doing these two today, and I'm realizing I need to share my screen differently, so give me just 1 second so that we can see like MetaMask and stuff here in a second. Okay, we're back. So yeah, I think someone is asking for a link to the slides. I'll put this in the chat one more time real quick. There's a link to the slides if you need them. So yeah, so ERCs, a lot of times those get referred to by their number. There's a ton of ERCs out there. The more common ones though, people are familiar with like 20 and 721. Cool. So what does a token standard look like? So we're going to talk about two different token standards today. We're going to talk about ERC-20 and ERC-721. ERC-20, that's going to be your fungible tokens, right? So tokens that are interchangeable, divisible. I like to think about them. It's about how many, not which one, right? So ERC-20 tokens could be used for things like USDC, right? It's a US dollar based stablecoin. Normally you hear coin, you're going to be thinking ERC-20 because you care about how many you have. It's kind of like dollars, right? If I have a dollar bill and you have a dollar bill and I take them and I shuffle them up and I'm like, hey, here's a dollar back. You're not going to care, right? As long as you got your dollar back. Whereas with the ERC-721, those are non-fungible tokens. It means you care about which one you have, right? So if you have something like a Picasso painting and I have my amazing one-of-a-kind stick figure art that I drew on a Post-it note, and I know it's amazing. It's a Richard original. And I shuffle them up and I'm like, oh, so you gave me the Picasso, right? Well, I shuffled them up and here's your artwork back. And I hand you back my stick figure. You're going to be like, wait a minute. You know, like this is not my Picasso. And you're going to be impressed because it's a Richard original stick figure Post-it note. I know. But those are non-fungible, right? You care about which one you have. So ERC-20, fungible. How many? Not which one. ERC-721, non-fungible. You care about which one you have. So cool. Fungible just means that you can swap them around. You don't care about which one. So when we look at these standards, right, we were talking about the standards for an ERC-20 token contract in this example. It has to have these functions and it has to have these events. If it doesn't implement these, it's not an ERC-20 contract. So we'll take a look at these in the actual contract as well. But we've got things like the total supply. It's like how many of this token exist. Balance of. You can get the balance of a specific account or address. You can transfer tokens between people. You can approve people to spend on your behalf. You can have an allowance check that returns the number of tokens that you can spend on someone's behalf with the approve function. And you can transfer from. So you can transfer from one account to another. And then there's events that get emitted. So there's transfer and approval that get emitted. So we'll build an ERC-20 token contract here in just a minute. And then we have an ERC-721 contract. Now you might look at these two, right, and see there's a lot of similarity. There's a lot of overlap, right? Like ERC-721, I see balance of. ERC-20, I see balance of. But then we have something different, right? This owner of and a token ID. This is because ERC-721 cares about which one you own, right? So for a specific token, who owns that one? We have the transfers, we have approve, we have set approval for managing sender's assets. Again, this is kind of allowing other people to do things on your behalf. And then we have events that get emitted as well. So we'll be deploying ERC-721 contract here in a little bit too. Somebody's asking, so would you use an ERC-20 for real estate property? That's a good question. Let's talk about this real quick. You want to tokenize something, right? An ERC-20 for real estate property, it depends. For a specific piece of property, like this is the deed to my house, I would say that should probably be a 721, right? I don't necessarily care about how many deeds I have. I care about which deed I have. If you wanted to take a piece of real estate and break it up and like share it amongst a bunch of people, then that might be an ERC-20 for that specific piece of real estate, right? So like, you know, this kind of like fractionalized ownership. This piece of property has 100 tokens. And so you own, 20 tokens out of the 100. That could be an ERC-20 because you don't care which token you own. You care about how many in that case. So again, it depends. All right, so smart contract libraries. We're getting close. We're going to get hands-on here, y'all. We're going to get close to being hands-on. Smart contract libraries. Libraries are a very, very useful tool because they allow you to import code. So you don't have to write all this code by yourself. It is an amazing thing to be able to import code. You see this a lot in pretty much every programming language these days. You know, we have all sorts of code that we import. If you're familiar with like JavaScript, for example, in your package.json, you've got all these different libraries that you're importing and you build on top of all this other code. It's fantastic that, you know, especially in like the open source community here, we just build on top of all this work other people have done before. And it allows you as the developer to be very, very powerful very quickly because you can build on top of all the work, all the groundwork that other people have done. Libraries in Solidity are the same way. They allow you to import in code and all the hard work that other people have done for your project so that you can then use that in your project. And so we'll take a look at that here in just a minute. A few things to note though. So libraries are stateless, so they don't maintain state variables, right? They allow you to import the code, but not necessarily variables, not information that is stored within those contracts. Which is good, right? Because then you're starting fresh every time. So your variables aren't populated already. They're also reusable. This is what I mentioned. Like, you know, you've got the code sharing. Common logic is stored in a single place. You don't have to redo the same code over and over and over. You know, if you wanted to deploy 20 different ERC tokens or ERC-20 tokens, you wouldn't have to write out the basic contract for that every time. Hey, Sol, did you need to say something?
Yes, I'd like to help you with
you're on mute,
the
Sol.
link. Oh, yes. Oh, no sound? No? Wait a minute. I come back.
Yeah, well, 1 second. Okay, well, we'll wait for Sol to come back. Oh, she's back, maybe.
And now?
Nope, I can't hear you.
Go forward.
Oh, you can hear? Okay, everybody else can hear you. It's just me. I can't hear.
Okay. So I'd like to help you with the QR code of our presentation. If you refresh your slides and go to the slide number 5, this is the best way to share the presentation. And I can drop off the link on the chat as well.
This one?
Yes. Yes.
Sorry, we're on like a delay because I am listening to you through YouTube right now. Okay, so if you need these, you've got this as well. Okay, sorry, y'all. I'm trying to mute everything so I don't hear myself now from YouTube. Oops. 1 second. Wouldn't be a good live presentation without some sort of trouble. Cool. Okay. We're back. Okay. So we talked about all this, token standards, ERC-20 contracts, wow, reusability. Okay, so we're back here to reusability. Allows you to import stuff, allows you to have code that you can just reuse, right? That's fantastic. Libraries also allow you to have a way to, they're different than standard contracts because they can be used through direct function calls as well. And we'll see what this looks like here in just a minute. They also can be more gas efficient as well, which is good. You have shared reference across contracts, and they're optimized for deployment. Like it's basically just the best of everything when you import, because you know that when you're importing from places like where we'll look at like Open Zeppelin, you have these industry standards. Will we have a recording? Yes, this is recorded because it's on YouTube. You can just back up, replay. It'll be here until YouTube goes away. And then smart contract libraries also are audited normally when they are, from a major player like Open Zeppelin, which we'll look at here in a minute. So you have more security as well, and that you're sure that this is something that is an industry standard. It's been audited, everything like that. So there's two different types of libraries that you can have. You can have embedded libraries that are deployed with the contract. So it's included in the bytecode. You can also have linked libraries that are deployed separately and then referenced at runtime, right? So one is you package everything up together and deploy it. The other is with like a linked library, you deploy your code and you reference code that's already deployed as well. So referencing stuff that's already deployed, that can be more gas efficient for large libraries, right? Because you're not deploying that code, which is great. Cool. Somebody's asking if we're going to use VS Code. I'm not going to be using VS Code in this bootcamp. We're going to be using Remix. So now we come to the point where I am going to maybe go off a little bit here because based on y'all's questions, I think we may need to take a step back. Real quick, in the chat, can you just drop like a +1 if you do not have a wallet set up at all, or you're like, what is a wallet? Can you just drop that in the chat real quick? So if you do not have a wallet, no wallet, what's a wallet? Drop a +1. If we get a bunch of them, we're going to go through setting up a wallet. Okay, cool. Yeah, it seems like we should set up a wallet. Let me... Okay, yeah. A lot of people need a wallet set. Cool. We will kind of go through this in just a second here. I need to figure out where I want to do this because I was not planning on doing this. Cool. Yeah, give me 1 second here. Let's see. Okay, we're going to pop Google Chrome over here. I'm going to get rid of MetaMask real quick. Yeah, I know. You're sorry to see me go. I'm sorry to see me go too, MetaMask. Okay. Whoops. I did not mean to close all of Chrome. Cool. So a wallet. What is a wallet? Real quick. A wallet is how you store your identity on a blockchain. I think probably it's like, having your ID card and your credit card and everything like that in your actual physical wallet. A wallet in the blockchain terms is how you're going to store that information as well. So let's go through setting up real quick a wallet. I'll try to do this quickly. So if you've already got one, maybe go grab a drink of coffee or something real quick. But if you aren't set up with one, we'll go through this and get it sorted out. So if you go to metamask.io, you should be able to get MetaMask, right? So, oops, that's the wrong window. I'm trying to make bigger, y'all. Okay, so we should be able to get MetaMask. We're going to add it to Chrome. This is going to add an extension to Chrome. And we'll see here, MetaMask, right? It's going to ask us to agree to the terms of service. And we're going to create a new wallet. If you use a different wallet other than MetaMask and like you're good to go, that's fantastic. So we can choose whether or not we want to improve MetaMask, and then we need to create a password. So this password is just for MetaMask. It's not for your actual private information within the blockchain. So, make it good and make it something that you can remember. We want to make sure that we have an extra strong password, not like me who has a weak password, woof, but something extra strong for yours would be good. We'll create a new wallet. And then here is where we're going to get into some stuff that you shouldn't share with anybody, right? So your password, that's important not to share. Make sure that's private. But then we're going to get into our secret recovery phrase. This is going to be 12 words that basically create our wallet. So these 12 words are encrypted to create our private key. Private key as the name implies, should be kept private. Anybody who has access to your private key or these 12 words has complete access to your account when it comes to your wallet. So remember that. I'm going to show you my private key because I'm going to throw this wallet away and never use it again. So it's going to be useless as soon as I stream my private key. So just keep that in mind. Your private key, your 12 phrases or your 12 words, those should be kept private. So we're going to make sure nobody's looking. All 854 of you, you're not looking, right? Like I'm sure nobody's looking. Cool. I'm glad nobody's looking too. So I'm going to need these in a minute. If you're following along at home, make sure that you write down your 12 words somewhere secure. It kind of gives you great instructions here, right? Like write them down, store them in multiple secret places, store it in a safety deposit box, for example. These are the things that will create your private key. So, if any of you saw these, that'd be terrible. But yeah, screenshot. That's what I did. Like I screenshot it because I'm going to need it in a second. Once you've written them down, you need to verify. They're like, hey, we just want to make sure that you wrote those down. So we're going to ask you for a couple of them just to make sure that you know what they are. And so it'll ask you to fill them in. So this is why I screenshot them, because I needed to fill them in. I'm not hacked. It's not hacking if it's consensual. So yay, I know what my private key is. So we've got our wallets. Cool. The next thing it says is like, hey, up here, we're going to add the little plugin. And so we can go up here and we can click on this little tiny, I'm sorry, it's so tiny, I can't make it bigger on this screen. Little tiny pin. So that MetaMask is always there. It's your little buddy MetaMask. It's always there. And we're done. Cool. So now I can click on this little fox up here and we can see our account up here. Cool. So just like that, if you've been following along, you have now got a wallet set up. Your wallet doesn't have anything in it though, right? It's empty. No monies. A couple things to look at. If you're here in the little fox, it's this little drop down right there. If you've got it full screen like me, you pick Ethereum mainnet. And if you scroll all the way to the bottom, there's this show test networks. We're going to turn that on. That'll give us access to a couple other things. So we click on the network here, Ethereum mainnet, scroll down to the bottom, click show test networks. And this will allow us to see test networks, which are a great place to do things like we're going to do, deploy tokens and stuff like that, development work, testing things. Ethereum mainnet, real money. Ethereum Sepolia is a test network, monopoly money. It still works like real money, but it's not real money. It shouldn't have any actual value. Cool. Cool. Darby's pointing out something great here. People are asking, like, how do we go from those 12 words to an actual passphrase for your private key? So these 12 words are hashed together. This is where like the cryptography piece comes in. So these 12 words get hashed into a value that is your private key. What does a private key look like? Sure. Why don't I show you? This account doesn't matter. Where's that? Private key here. Account details. Yeah, show private key. Look at this, man. MetaMask is like, you fool. Do not disclose this to anyone. And I'm like, ha ha ha, you're not the boss of me, MetaMask. I can show everybody my private key. So this string of numbers and letters is the private key for this account. So those 12 words get hashed together into this hash, and this is what you use for your private key. The way that wallets work in the blockchain is you have two things. You have a private public key pair. So these two things work together. Kind of getting like off into the weeds here a little bit, but the private key is used to sign transactions. Your public key is used to verify that signature. So given the information and the signature, I can verify that it was you, whoever controls this private key, that actually did that signing. So this is like how at a high level, the blockchain works. Yes, somebody in here, man, this right here, this is like solid advice. Never, ever give your private key to anyone, ever. I think I would just stop there. But, unless you want to lose everything, like, again, if somebody has access to those 12 words or this private key, they have access to your account, right? So it's solid advice there. Private keys should be private. Don't be like this guy, posting them on the internet like a fool. We good? I think we're good. Okay, so we've got a wallet set up. Fantastic. Give me just a second here. I'm going to go rejigger some stuff around because I need my comments back. Okay. Cool. So we've got, oh man, look at what this guy just sharing his 12 words still. Whoa. Okay. So we've got MetaMask, right? And like, I don't know about y'all, but looking at MetaMask, this always freaks me out. So like, see this little fox? See him? He's cute, right? Like he's looking around, looking at my mouse. When I start typing my password, he snoops. He snoops so bad on your password. It's ridiculous. Okay. So following along, you've got links to the slides. If you don't have links to the slides, I'm going to put them back in the chat again. I'm actually going to, and we are on this lovely slide talking about setting up your wallet. If you want to click these links, first one we're going to click is for the Chainlink documentation. We haven't talked about the Chainlink documentation yet. It's amazing. The Chainlink docs at docs.chain.link are fantastic. What we are interested in is this section right here, Ronin Saigon testnet. This is talking about the link token and how to set it up and add it to your wallet. But the nice thing about this is we're going to be using the Ronin Saigon network for our deployments. If we click add to wallet right here, it's going to like prompt us to add the actual network. So yours will probably look like this: switch network and add to wallet. When you click on this for the Saigon test network, it'll do something similar to this, where it's going to be like, hey, do you want to add Saigon testnet to your wallet? And you'll say, yes, I do. What's awesome is that just added it as an option here so that we can change to it, right? So you should see Saigon testnet in your wallet. So switch network, add to wallet for Ronin Saigon. That's what you want to click. That'll get you set up where you've got Ronin Saigon added to your wallet. So if you click on your little fox, top left-hand corner, you probably don't have quite so many enabled networks, but you should see one named Saigon testnet. You select that, and that means you've got it added. Somebody's asking, why are there so many testnets for the same blockchain? So these are actually all different blockchains, which is kind of cool. So they're set up like different ways of reaching finality. So like all agreeing that everything is set up the same way. And yes, like everywhere it should be Saigon. It's a good question, but like Saigon is the name of the actual testnet. So it's distributed all over the place. Cool. So we've got Ronin Saigon added to our wallet. The next thing that we're going to do is we're going to go get some funds, right? So we mentioned that testnets are like monopoly money. If we go to faucet.roninchain.com here, we can get some funds for our wallet. Now it's going to ask you for your Ronin address. So if we go to MetaMask or your wallet, you should be able to copy your address. And I'm sorry, this is so small. I can't make MetaMask larger. So the little fox right underneath the account name, it's going to have this little copy to clipboard here. We'll copy our address and we'll paste it in. And then we're going to select our token. We're going to say 1 RON. And we'll send our request. And it's going to say, hey, we just want to make sure that you're not a robot. So we'll need to make their little axie guy be right side up. We'll confirm that. And our request is submitted. So at this point, it's going to be sending you 1 RON. I don't know how you say it. RON. I like RON. 1 RON to your wallet. Okay. If you click send request again, it'll be doing it again. So each time you click send request, it'll send you 1. You can get up to 5 per day. So Ron is an ERC-20 token, right? And this is what we're going to use to pay for our transactions on Ronin Saigon on the blockchain. So once you've done that, you should see you have a balance in your portfolio. If you go to tokens, you should see that you have some. I have a ridiculous amount in case we need it for stuff later. But yeah, you should see here that you have a couple Roan after you've done these requests. Cool. The faucet is at faucet.roninchain.com. It's also here in the slideshow as well. Cool. So we've got that. Yeah, Liam, it is a free money glitch because it's not really money. So it's fine. It's just like Monopoly bucks. So the next one is if we go to faucets.chain.link. Here we can get some link tokens, which we'll need later as well. So if we go here, we just have our link token selected, and we click continue. It's going to fill in. I probably skipped a step because I've already connected my wallet. It's going to prompt you in the top right-hand corner to connect your wallet as well. Let me run through what that looks like for y'all real quick. Where is... Disconnect. Cool. So yours should look like this, right? So we're on Ronin Saigon. It says connect wallet up here in the top right-hand corner. We'll click that. We'll accept, and we'll say we want to use MetaMask. And then we'll click connect right here. Once it's connected, then we click continue down here at the bottom. And we'll say, hey, get tokens. And we'll confirm. And that'll send us 25 link tokens as well. You're going to use Ronin Saigon testnet to add the network. Cool. Okay. So with that, when we were here too on the link token contracts, if it's not showing up the link in your wallet, you can click add to wallet, add the token, and then you should be able to see under MetaMask, under tokens, you should see your RON, you should see your link as well. Cool. Yes, we'll need link, not today, but I'm just setting you up for success in the future. And so yes, that's how you're going to pay for the Chainlink services that you'll be using tomorrow, definitely on Wednesday. Okay. So we've got our wallet set up. Awesome. Whew. Okay. So next we're going to talk about Open Zeppelin and their contracts wizard. Yeah. So Open Zeppelin is probably like one of the biggest industry standards when it comes to contracts in this space. We were going to use them for both the ERC-20 and the ERC-721 contract as well. So if we go to this link, wizard.openzeppelin.com, you should see their contracts wizard. Whoops, I picked the wrong one. Contracts wizard here. This is a pretty awesome tool to build out smart contracts. So you can see here, it starts off, how big can I make this? That seems good. It starts off on the ERC-20 contract. This is a contract that we're going to use. There's also 721, which we'll be using in a little bit. They've also got, these other ones, ERC-1155, stablecoin, real world assets, governor, custom. Whew, that's a lot of stuff. We're just going to talk about these two today. So ERC-20, again, those are fungible tokens, right? Tokens that we care about how many, not which ones. And you can deploy your token from Remix. So we'll click open in Remix here in just a moment. But maybe you want to name your token something different other than my token. You're like, that's not his token, it's my token, right? So you could name it like your token, whatever you wanted. So, your token. It's pretty cool. You'll see, hey, look at that. You change it here, it changes it over here. This is the actual code, right? Pre-mint, like how much you want to create at the beginning before, like when the contract is deployed. Set that up there too. Do you want people to be able to mint it later? What does mint mean? I'm just realizing this may be a foreign word to some of you. Minting is creating. It makes a lot of sense when you think about tokens, right? Like think about actual coins. Like an actual coin, this is not like money coin, but it's a coin. When you create a coin, you mint it, right? Like it's like you stamp it out and you actually create that coin. So that's what you're doing here. You're minting coins. If you want this to be mintable later, you can check features, make it mintable. If you want to be able to pause minting, you can just check the box here and pause minting. And you'll notice when I'm checking these boxes, right, like a lot is changing over here on the right. So like we'll just look at pausable, for example, right? So turn it on, turn it off, turn it on. You'll notice like this whole thing comes in there. Turn it off. Like there's also this function pause and unpause that gets added in, and update gets added in down here. So what's all this doing? We're probably not going to leave pausable turned on, but let's talk about it. So this is importing in the code from another contract, right? So this contract here, and sorry, I just clicked on, like if you just click on one of these, there are little links to the actual code. So this is showing you like the power of imports. So this is being imported from this ERC-20 pausable.sol. If we take a look at that here, like when we clicked on the link, so it's actually importing other stuff, right? So it's like importception, but it imports in this function. So what all does that import? Well, it imports, whatever's in pausable and whatever's in ERC-20 as well. So if we wanted to look at ERC-20, it'd be this contract here. And you'll notice this contract imports a bunch of stuff. And like, so here's the code under ERC-20, right? So all this code, like that's a lot of code, right? Like we're just going for days here. All that code is imported with this one little line. Kind of gives you an idea of like the power of importing, right? And so that code's already been audited. It gets deployed all the time. It's secure. And one line, you get to import that in. It's pretty cool. So you've got your token. You've got your symbol for your token. You can decide how much you want to mint with it, like when it's deployed. I'm going to leave mintable turned on. And then I'm going to leave permit turned on. Why do I need this? I don't need this. I'm just going to leave mintable turned on. We'll keep it super, super duper simple. So this is our whole contract, right? So how do we actually deploy this? I've never clicked this deploy button. We're not going to click it. We're going to click open in remix. So you've named your token, you've got your pre-mint, you've clicked mintable, and now we're going to click open in remix. So this is going to take us to Remix. Remix is an online IDE. It's a development environment. Basically, it'll let you do things like compile your code, write your code, check to make sure your code is correct, and deploy your code, interact with deployed contracts. It's pretty powerful. It's pretty awesome. Somebody's asking, what if you leave mintable off and pre-mint 100? Does that mean the total supply of the coin is 100? Yes. You got it. So we've got our code here in our window. I'm going to get rid of this stuff on the side. Yours is probably in dark mode because Remix defaults to dark mode. Those of you who were complaining about it being so bright earlier, you're welcome. Remix has got your back. Sorry, I don't. This contract, we'll walk through it, right? We've got our Pragma. So this is our compiler version. We've got our imports here. So we're importing in two things. One is all of Open Zeppelin's contracts for ERC-20s. Two is ownable. We talked about modifiers earlier, right? When we were looking at that owner thing as well. This one is using ownable, which is a modifier. We can see here that the mint function on line 16 has this modifier only owner. That means that only the person who deployed this can call the mint function. So when I deploy this, it's public, but only I will be able to call mint function to create more coins. Cool. So we've got our contract. Mine is called your token. It's a ERC-20 contract. Wow, these little pop-ups are rough. It's an ERC-20 contract that is ownable. In the constructor, you can see the constructor takes in two things. The first is the recipient. And the second is going to be the initial owner. It then creates an ERC-20 token with the name and symbol and sets the initial owner for ownable. And then it calls the mint function to the recipient with 100 actual tokens going to them. Cool. So let's actually get this deployed. If we click on the compiler, it's a Solidity logo here. You can see it's kind of like a cool stylized S. If we click on that, you may not have a green checkbox yet, or check mark, right? That means that everything is working and it's good. If you don't have this yet, you have two different options. The first is to turn on auto compile, or you can click compile. Either one of those will work. So once we've got that turned on, you should see a green little check mark. If you did something silly like this won't work, you'll notice, oh no, it doesn't compile, it fails. And it tells you like, hey, here's the problem. Here's where it's at. But if you just clicked open in remix from Open Zeppelin, you should be good to go. Cool. I think we're all set up and ready to go. We've got this. We've got our green checkbox here. We're going to go down one to the Ethereum logo with a little arrow on it for deploy and run. We'll click on that. And we can deploy our token here momentarily. The first thing we need to do is we need to change from Remix to our injected provider MetaMask. So this VM, it's a virtual version of the blockchain. It's great because like you can deploy there and it's like done, fast, easy peasy. But we won't actually be able to interact with it the same way that we will when we inject our MetaMask provider. Injected provider just says, hey, take MetaMask from up here in my browser, inject it straight into Remix. So we'll pick that. You may get a pop-up that's asking you to connect MetaMask to Remix. Go ahead and accept that. And you'll notice some things change, like your custom network now. It should say 2021 if you are on Saigon. So it should say that. You'll see your account here. And then we'll take our account. So right here where it says account, we'll copy that. So we click this little copy button because we're going to need that down here in the deploy tab. If we click this little down arrow right here, we can see that it's asking for two different addresses. One is the recipient, one is the initial owner. Fun fact, it's going to be us for both of them. So you'll paste in your account. Remember, we copied it from here into both of those, and we're going to click transact. Now you may notice this button, transact, is orange. I think in the dark mode, yes, in the dark mode, it's like the same color orange, I'm pretty sure. Orange buttons in Remix are ones that are going to cost you something. So when I click this, you'll notice MetaMask pops up and it's like, hey, it's going to cost you a fee. Can I make this bigger? Did I lie this whole time? Oh, I can kind of make it bigger. Let's go. Okay, so you can see here, it's going to cost us like 0.0311 RON, right? So this is how much it's going to cost to actually deploy this. We'll click confirm. And there's a couple things we can look at here. So up here in MetaMask, you'll see our contract deployment is pending and confirmed. That was very fast, but it said pending like for just a second. That's why we're waiting for the blockchain to go and do its blockchain stuff and for all the nodes to agree and everything like that. Down here at the bottom, we got a green check mark. That means, hey, your transaction went through and it was good. If we scroll down a little bit, you'll see here under deployed contracts, your token. If you named your token differently, it'll be called whatever your token's called. Under your token, we've got a ton of different things that we can do, right? Like all of these functions are part of our contract. Now, again, you're probably looking at all this stuff and you're like, look at all these functions. There's so many functions. There's gizmos and gadgets galore right here. Like, it's crazy. The only function that we said that we were going to create was this one, right? Mint. Like, where did approve, renounce ownership, transfer, all of these, where did these come from? And you may be thinking, if you were paying attention earlier, approve, renounce ownership, transfer from. These look oddly familiar. I feel like Richard showed me these before. And if we go all the way back to our ERC-20 contract standard, you're going to see approve, transfer from, balance of, transfer. Whoa, look at that. It's like the ERC standard is coming through in our ERC-20 token. So all of these different functions, those are coming from our import here. So within this contract, right, we've got all of these different functions. It's pretty awesome. Again, this is the power of the imports. It lets you have this tiny bit of code that you wrote enable all of this over here, which is pretty amazing. Cool. So what can we do with this, right? Well, first of all, we can check things like the name of our token. It's your token. Who's the owner of our token? It's going to give you back this crazy long string of numbers and letters. That's your wallet address. And then our symbol, right? The total supply, like how much of this token exists. And when you see this, you're going to be like, whoa, Richard. Hold on a second. That is a very big number. And when we told Open Zeppelin, we wanted 100. Like that number is way more than 100, right? Like, do we all agree? That's way more than 100. So why is this number so large? Let's pop it over here real quick. We're going to look at one other thing real quick. It's called decimals. In the blockchain environment, there are only whole numbers. So when you want to use like a small fraction, like when we paid for our transaction up here, right? You remember it cost us 0.03 RON, right? 0.03. We don't have those in the blockchain really. We have whole numbers, but we've got decimals here as a value. So this decimals is going to say 18 decimals. So instead of our decimal place being here, we're coming over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 spots. And our decimal actually belongs right here. So now it looks like we minted the correct amount, right? So we minted 100 of them. It's just, they're like this because we don't have decimals in this value. Somebody asked earlier, this mint function here, like what the heck is this, right? Well, let's check it out. We said we wanted to mint 100 of them, right? So we want 100 of them. And then we want to multiply that by 10 because that's how many times we want to move the decimal place over times the number of decimals that we have, which in this case was 18, right? So 100 times 10 times 18 gives us this number. So the 10 is basically to say, you know, like how many decimal places do we want to use? Because times 10 just basically moves the decimal place, right? Divided by 10 would move it to the left. Times 10 moves it to the right. Does that make sense? Hope that makes sense. Cool. I feel like there's a lot of chatter going on, but I've been keeping an eye on it. It looks like you all are helping each other out, which is fantastic. Oh, yes, you're right. Sorry. It is times. Somebody pointed out, yes, it is to the power of. So times means like raised to the 18th power. Good call. Cool. So can I just get like a +1 in the chat if you deployed this contract? And like a +2 if this was the first contract you've ever deployed? Man, that's pretty cool. A lot of people first contract deployed. You're successful. That's amazing. I don't know, like give yourself a pat on the back. Like that's stinking awesome. Man, a lot of people deployed this too. That's awesome. Dude, I'm proud of y'all. Good work. All right. So we've got our ERC-20 token deployed. If we want to check this out a little bit more, we could get crazy here. We could copy our token address, right? So copy this address right here. So deployed contracts, your token, whoops, copy this address right here. We could go up into MetaMask. And I don't think I make, this is the window I can't make bigger. Oh, expand view. Okay, so we'll go into MetaMask and we're going to go to tokens. So remember, we came here on Remix, we copied our address, right? So copied, go into MetaMask, go to tokens, click on these 3 dots right here. So under tokens, import token. We can pop in our contract address right here. And what's pretty cool is it already knows the symbol and the decimals. We'll click next, click import, and you've got your token right here in your wallet, which is pretty cool. I think that's pretty cool. So it already knows everything because on the blockchain, things can be read by other places, other tools, which is awesome. Oh no, Ray, deployed on mainnet. I'm sorry for your loss. At least it's not too bad. It wouldn't be too much money. Cool. Somebody's asking, does deploying tokens on testnets have the same requirements as it does on mainnets? So, Ray, I'm going to use your example, but Ray proves that it absolutely is exactly the same. All you'd have to do, if you wanted to deploy this instead of Saigon testnet, if I wanted to deploy it on an actual mainnet, right, I could just pop into Ronin mainnet or Ethereum mainnet here. And if I had funds, I just put in my addresses and click transact, and away it would go, and it would deploy. So yes, this is the real, it's the reason for testnets is that you can do everything, make sure everything works, and test that everything is working correctly, and then deploy it. So yeah, cool. If you need to see how we deploy again, if you were lost with something, just back the video up. Back the video up. It'll be okay. Cool. So we deployed our contract. I guess I'll make sure I covered everything about the Remix IDE. I feel like y'all did a great job just kind of, sticking with me as we went through Remix. So real quick, breaking down the Remix IDE. We've got a few things. You'll notice this is dark mode. It looks different. It's foreign. It's strange. But we have the first little tab up here is going to be our files. This here is going to be the compiler, right? That's what we looked at earlier. That's where we actually turned on auto compile. We click the compile button. The next one down is deploy and run transactions, which is where we actually deployed our contract right here. Oh no, my contract's gone. 1 second, I will get it back. So here we have our deployed contract, right? Wait, 1Password. We can do things like say we wanted to mint some more tokens. Who wants some of my token? First person, I'm only gonna do one. Pop your address into the chat real quick, and I'll mint you some of these commemorative your tokens from the workshop. Their value will increase exponentially, considering they're currently at 0. But we can mint tokens here. Oh, we got a winner. To a different wallet. We can do lots of stuff, right? So deploy and run transactions. Do we actually get to go through? Yeah, you should be able to have these in your wallet. Yeah, so that's how Remix works. So we've got our compiler tab. We talked about ABIs earlier. If you ever need the ABI for your contract, down here at the bottom is this little tiny button. This is where you copy that ABI from. If you wanted to see like what the heck does this actually look like when it's compiled, like you can copy the bytecode and we can take a look here. Yeah. All this, it's all on one line. But this is the actual contract when it's deployed, right? So like, aren't you glad that we don't work in bytecode, that we work in Solidity? Because this would be way more confusing to have to type this out. This is our compiled contract right here. It's pretty crazy. Yeah. So that's Remix. We deployed our token, our ERC-20 token. We minted our token, right? You followed along. That was awesome. Now we're going to talk about NFTs. So non-fungible tokens. So what we just did was a FT, I guess. Nobody calls them FTs. They call them ERC-20s. But it was a fungible token. Now we're going to talk about non-fungible tokens. So non-fungible tokens represent a thing, right? So they could be tickets to like an event. They could be real estate. We talked about real estate earlier, how you could kind of use both. Art, we talked about that in the example, right? Like I traded you my amazing hand-drawn, one-of-a-kind stick figure post-it note for your Picasso. It was amazing. Badges, trading cards, stuff. So NFTs are a thing. They represent something. Normally, they're going to have some sort of asset associated with them. A lot of times, maybe not normally. A lot of times, they have some sort of asset associated with them. So like an image, music, something like that, something that they're associated with, some sort of asset. Generally, those are stored off chain because storing things on chain is very expensive. There are ways to store them on chain, but a lot of times, most commonly, I would say they're stored off chain, like the actual asset itself. So what your NFT really is, it's a non-fungible token that points to something else. So it's kind of like just like a deed, right? Or a title to your car or a deed to your house, right? That piece of paper says you own this thing, but that piece of paper is not the thing that you own. I think that should make sense, right? So NFT says you own this thing, but it's not the thing that you own. So this information can be stored off chain. A lot of times IPFS is used. IPFS stands for Interplanetary File System. It's a distributed storage place for storing information like pictures, stuff like that. Some examples are like Pinata, Infura, QuickNode. They all have IPFS solutions. For most of my examples, I've used Pinata, which is just, it's a little place to store your files. So you store them up there. It's distributed storage. You can yourself have a Pinata node, an IPFS node, and you can ensure that that thing that you're storing will always be available as long as yours is up, but other people can also store it. Pinata is one of those other people who can also store it. Cool. So within a NFT, right? So hopefully you're familiar with OpenSea. If you're not, we can go take a look real quick at OpenSea. Let me just connect real quick and we'll look at one of my amazing NFTs. Cool. Look at this little dude. So we've got this little cross-chain character, right? And it's got all this information about him, his details, his stats. Oh, this one doesn't have stats. Let's go back. Let's look at this. We'll look at this. We're going to make these flowers today. So you can see here, they've got traits like this, blooms, the color, some details about it, right? Like where it is, when I made it 4 days ago when I was prepping for this workshop, everything like that. It tells you all about it. It's got its name up here, right? All of this information is stored either on the blockchain or off chain. So we are going to create an NFT that stores this information off chain, but this metadata is in JSON object. You remember JSON that we talked about earlier? Man, every time I say JSON, in my brain here, Derulo. But we've got this metadata. So in this example here, right, we've got Herbie Starbelly, this cute little jellyfish. Talks about, his name, his description, this external link, his traits, right? Like where his image is, all that stuff. So this is all coming from the NFT. We'll take a look at the actual code here in a minute. So we've got that JSON metadata. Got the names, descriptions, image, attributes, all that stuff. We're going to build our own, right? So we've got OpenZeppelin again. If we went back to OpenZeppelin here in the wizard, we could say ERC-721. That's an NFT. That's the ERC standard for 721. We could name it something if we wanted to, like, my awesome NFT. Man, my awesome NFT. I like that. It's man token. We've got this base URI. So URI is going to be like where the information for the NFT, where that metadata is stored. So we could turn on URI storage if we wanted to do that and store some information there. We can make them mintable. We can increment their IDs. There's a lot of buttons to click here. We're not going to use this because I went and made a custom version for y'all to use for this that has all the stuff in it. So if we come here to this gist, you'll see some code. So what we need to do is we need to copy all 60 lines of code here. I find that the easiest way to do this is to click raw and then just Control or Command A, copy, right? So just highlight all this. So it's tiny. I know it's tiny. We don't need to see it though. We just need to copy it. We're going to copy it. We're going to go back to Remix where we were before. Oh yeah, it might be good. I'll pop this link in the chat. Where are we at? Here? Here, yeah. Okay, so we copied this, right? We said raw, copy all this. Went back to Remix. We're gonna go up here to File Explorer. We're gonna select a different workspace. So this code sample, this is from Open Zeppelin. We're going to go back to default workspace. Okay, so File Explorer, Workspaces, default workspace. Contracts. You probably just have 1, 2, 3. If you have nothing here, that's fine. Don't worry about it. We're going to say new file, and we're going to call it. We're going to call it. What's this? What's this called? This is called Bloom's Collection. So we're going to call it Bloom's Collection. So we're going to go here, contracts, new file, Bloom's Collection.sol for Solidity. And then we're going to paste in all this code. And Remix is like, whoa, whoa, whoa. Hold on. You just pasted a bunch of code, dude. Do you know what you're doing? Like, make sure that it's from a trusted party. And I look in the mirror every morning and I think to myself, do I trust myself today? And this morning I said, yes, I trust myself. So I closed this window because I trust myself this morning. Cool. So now we've got our code in here. Somebody's saying that their Remix environment is stuck on Sepolia, which you used previously. If you're not on Ronin, you can go right up here to MetaMask, select the correct network, Saigon test network. And then when we deploy, we'll make sure that we choose injected provider, and that should get you there. But we're not there yet. No skipping ahead. So let's take a look at this contract real quick and figure out what the heck is going on. What are we doing here? So we've got our compiler version. Somebody asked what this little caret means. That basically means like use this or anything after it that is still within the same, I forget what this is called, but it's the same version, right? So like we're not doing a major version. We're only doing minor versions. This is part of semantic versioning. Not to get into it, but basically it's saying like we can go up a little bit from here as far as versions go, or down just a little bit. I think, no, up only from here, up just a little bit from here with versions. As long as they're not breaking, this is what this will help you do. Cool. We've got our imports, right? So this time we're importing ERC-2021 and some URI storage stuff. Like, what is that? We'll look at that in a minute. And Ownable. Hey, it's our buddy Ownable. We used them before. Cool. So we've got our contract. This contract is called Bloom's Collection. It's going to be a collection of blooms. It's beautiful. We have a private. What does that mean? That means it's only available inside this contract variable called a next token ID. We also have a private constant. That means it doesn't change, constant. Default URI. This is going to be all that metadata for our token. In this case, you'll see, hey, look at that. It's on IPFS. And IPFS references things with hashes because they never change once they're stored there. So we've got our hash for our purpleblooms.json. Let's check that out. So I'm going to click on this and take a look here and see what our metadata looks like. We're doing on time. We're good on time. So here is our metadata. That's pretty print. Oh, nice. Our metadata is our name, Purple Friendship Blooms. Description, keep sharing or the blossom will die. This is from a different project I made. So this blossom will not die. This description is a lie. Our image is also on IPFS, so we'll take a look at that here in just a minute. And then we have, the stage and the color. So if we take a look at the blooms themselves, oh my goodness, those are gigantic. We can see that lovely JPEG image that we saw on OpenSea a moment ago. Pretty cool. So this is the metadata that is behind our NFT. But something to just kind of remember, it's on the blockchain. This pointer is immutable, and it's pointing to a place that is kind of immutable as well. But this could just be, like my Twitter profile picture, right? Instead of that flower picture. So it could change. It just depends on what it's pointing to. So this is pointing off the blockchain. We've got our constructor here where we set up, the name and the owner. And we've got our mint function as well. This one has two different mint functions. It's kind of a little bit strange, but the reason that we have this is the original mint function. It wants to take in a URI, which is going to be that metadata location. I made another one that just takes a to address because that metadata is always going to be the same. So a lot of good questions about NFTs in the chat. Somebody's asking, can you build dynamic NFTs with this? No, you cannot. If you go look at Chainlink's YouTube, you should be able to find me talking about dynamic NFTs though at some point in the past. And that you can do. It's not too much different than this. Somebody's also asking, is it possible to update the metadata later after minted? Yes, it is. That goes back to the question about dynamic NFTs. Okay, so we've got our mint functionality, and then we've got our token URI. This is going to be the metadata that is returned. And then we have this supports interface. This is just required by OpenZeppelin's ERC-721 contract. Don't worry about it. Cool. So I think at this point, we're ready to deploy, right? If you don't have a green checkbox, what does that mean? It means you didn't turn on auto compile right here. So you could click compile and get that green checkbox. And then we'll go to deploy and run transactions. Make sure that you pick injected provider MetaMask. I know you're thinking I could use a vacation. I want to go to Cancun. It's not going to be good for us though. We need to go injected provider. We should see custom network 2021. We'll need to set our initial owner address, which is going to be your wallet address. We'll copy that from right here. You could also copy it from MetaMask up here in the corner if you wanted to. We'll paste that in here and click deploy. If you did everything correctly, you should see MetaMask saying, hey, would you like to deploy this? And you'll say, yes, I would like to deploy this. And you'll see it's pending. And then I got my little green checkbox. All right. We've got our deployed collection here. We can see, what the name of it is, all this stuff, right? Man, 1Password. What are you doing? We've got all that. We could see, what the balance of my address is if I wanted to do that. I don't have any because I haven't minted one, right? Like we deployed this. We're going to come up here to Safe Mint. There are two options. Right? One just has address to, the other one has address to and string URI. Don't use this one. Use the one that's just address. So you'll paste in your address there. Again, if you need your address, you can either get it from up here on account, copy right there, or you get it from MetaMask. Put it in there, Safe Mint, transact. We'll confirm this. Wait for the green checkbox. And now if we say balance of, we've got one, right? So I minted an NFT. Cool. We've minted an NFT. This is amazing. So what can we do with this, right? Like how can we see this NFT? Well, if we go to testnets.opensea.io, this is different than OpenSea's normal website. Normally it's just opensea.io. OpenSea lets you, it's kind of like an NFT marketplace. We want testnets.opensea.io because we are on a testnet. If we go here, up here in the top right, we should see like this login button. I'm going to say MetaMask. It's going to ask you if you want to connect, and then it's going to ask you to sign. We'll say, yes, we want to sign. Now we're logged in. You'll probably have a different color little circle up here. If you click on that, it should take you to your profile. Your profile, most likely, will be much more empty than mine because, man, I've made a lot of projects over this time when I've been doing stuff here. But you can see I had one, and now I've got this new one called Bloom's Collection. We can go check it out. You can see here that it was created like 1 minute ago, which is pretty cool. It's all the information about it, which is awesome. So yeah, with that, we've deployed an ERC-20 token, and we've deployed an ERC-721 token. I'm assuming if you hadn't deployed anything before when you deployed the ERC-20 token, you've never deployed an NFT before. So if you just deployed an NFT, man, Teddy's on board. He's already got that +1 in there. If you've never deployed an NFT, like, again, give yourself a pat on the back. That's amazing. Like, y'all are rocking it. It's fantastic. I think with that, we are like close to being done. Yeah, look at this, man. People deploying stuff. Oh, this is awesome. Again, if you got stuck, if you have questions, just back me up. Watch the video again. It should be pretty easy. What address is meant to be in the @ address space? So where are we at? This one? Yeah. So SafeMint 2. Oh, this. Ignore this. I didn't talk about this. I did something with this, but it was like behind the scenes. You saw nothing. So what this is, so this contract, right, is deployed here at this address. The address is whatever this is, right? So this is my NFT contract. If I had deployed this somewhere else, the reason I use this is because these deployed contracts, they go away. So like if I change this to Cancun, now you'll see like my deployed contract is gone. If I change it back to MetaMask, you'll see my deployed contract is still gone and I needed it. So what you can do is if you know the address of the contract, this contract over here in the window, if you know the address that it's deployed to, you can put it here instead of deploying it. You're saying, hey, this contract exists already on the blockchain at this address. And then that's why I used that. If you want to make sure that your contract doesn't go away, this little pin button, very useful. You click that and it'll be stored basically. So this will keep it if I go between Cancun, man, go away 1Password. If I go between Cancun, no deployed contracts, and now I come back to injected provider MetaMask, you can see my collection is still there because I pinned it. So there's something important to know. If you're like, oh man, I deployed this contract like last week and I don't remember where it is, but you minted something, for example, this Bloom's collection contract address is right here. It's also, so up there in the URL, it's also in the details. The contract address is right here. Cool. Some questions about OpenSea. What if we want to create our own without copying from, I'm assuming you mean OpenZeppelin, not OpenSea. How do we do that? So if you wanted to create your own without copying from OpenZeppelin, you would have to go ensure that your ERC-721 implemented all of these functions and events. So you'd have to like code this all out yourself as well. Cool. Okay, so with that being said, one last thing. So you're like, deployed your first smart contract today. And you're like, man, this is pretty cool. I want to learn more. You want to learn more? You go to dev.chain.link. Here, there's all sorts of tutorials, right? Deploy your first smart contract. Well, you already like passed this one up today. You want to learn about functions. You want to get started with data feeds. There's all sorts of different tutorials here. If you go to view all resources, man, there are tutorials galore. beginner tutorials, quick starts, all sorts of information here about Chainlink if you want to get into that. Also, if you come here to the dev.chain.link, you may see up here this Chainlink certification, right? Let's check this out. What is this? We go here. You want to get actual certification for all this hard work. This Chainlink fundamentals, we're covering part of that in this bootcamp. So you come here. So how do we get here? We went to dev.chain.link. We clicked on Chainlink certification. Took us here. We're gonna go here to Chainlink fundamentals. We can start this course. That's us to log in. We get a confirmation code. Once we're logged in, we can actually go through the course and learn all about all the different Chainlink products. It's pretty cool. But today, we did smart contract and Solidity fundamentals. If you look at this, you'll see like, hey, we learned a little about Solidity. We learned about smart contract libraries. Open Zeppelin contracts wizard. Y'all know about that. Build an ERC-20 token. Done. Build an NFT. Done. Man. And then it's like tomorrow, Sol's going to talk about oracles and data feeds. Sweet. And then Chainlink CCIP, Dave's going to talk about that on Wednesday. So like, a good chunk of this, you'll just have done. You can read the rest. It's all available for you anytime you want here. So dev.chain.link, certifications are there. I don't know. Do you have any like burning questions right at the end here? If not, we can call it a wrap, but I am excited for tomorrow. It can't get here soon enough because that's when the next part of the bootcamp starts with Solange. Well, cool. I guess that, something's saying 404. Did we post a bad link? Maybe it's this. Beep, beep. I don't know what's 404ing, but that shouldn't be 404ing because I'm there and, works on my computer. So yeah. Does it still say error with the link I just posted? The last one? It works now. Cool. Okay. Man, y'all are awesome. Thanks for being here. Like a lot of you saying thanks to me. Thanks to y'all, man. You guys make this job fun. You are a great group. Appreciate all the questions and everything. Yeah. And with that, I'm going to end the stream. I hope you come back tomorrow because it's going to be awesome. Till then, take it easy.